Hey guys, I'm not doing so well, but I'm going to try my best to do a short little video so you can play this and it goes along with the lesson. So I hope the quiz went well. And now we are starting our Unit 2, which you guys know linear functions. We did them in Algebra 1 and we did them in geometry as well. So we're going to look at how do we evaluate a linear function, and then we're going to look at slope and rate of change. So this should feel pretty easy lesson for you. All right, let's get started. Okay, so again, pretty much Algebra 1, I say, hey, can you solve for x? All right, so what would we do? Well, hopefully you're thinking we would distribute, right? We're going to try to simplify things. Make my pen a little bigger. There we go. And we would get 6x plus 24. And we're going to distribute again. Pay attention to signs. Negative 2x plus 2 equals 2x plus 20, right? There's nothing to do on the right side. But as you can see, we have like terms. Yes, like and like. Okay, so what are we going to do with those like terms? Well, we're going to put them together. 6x minus 2x is 4x. Oh, do you see two more like terms? 24 and 2 plus 26. Look how easy this is. Now we're going to, right, we have variables on both sides. So in order to isolate one, we have to move one over. So now you can think, all right, so what do I want to do next? Well, let's subtract the 2x from both sides. I'm just going to move this up here. And so what do we have here? We have 2x. And then kind of at the same time, I'm going to do the minus 26 from both sides because that'll be on the right side. And it'll give me a negative 6. And then last but not least, if I divide by 2 on both sides, I get x equals negative 3. Okay, so here you have a linear equation, and our solution is negative 3. Again, pretty much reminiscent, or should be reminiscent of Algebra 1. Now, when you get to Algebra 2, sometimes, as you can see written here, we get equations that actually have no solutions at all. And the vocabulary word that goes with that. So if you get an equation that doesn't actually have a solution, right, that's called an inconsistent equation. Other times we get an equation that, well, any value of x will work. So any value you could put in for x would make that equation true, and that is called an identity. So those are the two new vocabulary words that you need to associate with no solutions and any solutions work. Now let's take a look and see, well, what's that going to look like? It's going to look different than, obviously, I just solved, I got an answer, x equals negative 3. So let's go and take a look. Okay, next one. You'll notice that it says, what is the solution? Is it an identity, inconsistent, or neither? And again, neither is your equation has a solution. So this one looks pretty similar to the one that we just did. Let's again take a little look here. All right, so I'm going to distribute once again and get negative 2x minus 8. Going to distribute on the right side. 3x plus 6 plus x minus 5. Okay. What do I do next? Oh, again, those like terms. And like terms on the right. And more like terms with 6 and negative 5. That's a 4. All right. So now kind of look what's happening here, right? I have 4x and 4x. Well, let's try to continue to solve it. All right, what would we do? We would go minus 4x and minus 4x. And then ultimately what's going to happen is we're going to get negative 8 equals 1. But that's not true. Negative 8 does not equal 1. So I want to put a does not equal. And notice that I don't have any solution for x. X doesn't equal anything. So this is no solution. Right? You have to write that there is no solution. And then the type of equation would be inconsistent. All right, so that's what that looks like. Let's look at the next one. Okay, so let's look again. What are ways that I can simplify this? Well, don't be bothered by this because we can really simplify that pretty easily because 4x plus 2 divided by 2 is just 2x plus 1, right? Plus 8 equals 2x plus 9. All right, what's happening over here? Well, looking, again, similar but different. So what do I have? Oh, I have 9 if I add those together, right? So 2x plus 9 equals 2x plus 9. Huh, interesting. Right, and I could have, just by the way, if I had subtracted the 8 in the beginning, right, from both sides, I would have gotten 2x plus 1 equals 2x plus 1. It really doesn't matter. What you need to notice, right, is that even if I take this further, I mean, you should notice that the left side is identical to the right side right now. But if I take this one step further, right, and let's say I go and I subtract the 2x like I did above, you're going to get 9 equals 9. And that's true. And again, no matter what I put in for x, right, I'm always going to get out, right, the same thing on the left as the same thing as the right. So this actually says that all real numbers, right, is the solution. There's an infinite, I'm going to write that another way. There's an infinite, infinite number of solutions. Any real number I put in is going to work. Now, what type of equation does that give us? That gives us an identity. Right? Think about it. The left side equals the right side. It's identical. That's a good hint to know when you have an identity. All right, and that's all there is to looking at those. You'll have, remember, this is a shortened lesson, so I'm just doing these with you. You're going to practice this on the homework. All right, if you look at our next phase of linear equations, this should look very familiar from geometry. So we have the slope-intercept method, and we have slope-intercept equation and the point-slope equation. So basically, there are two different equations, right, that we can write that represent a line. It's basically what it is. What's the difference? Well, one uses the slope and the y-intercept. I would have to know the y-intercept. And you can see that in our example. Or the other one is I have to just know, again, the slope, but just any old point that's on the line. Okay? And let's not forget that's a fancy way of saying slope is average rate of change. So when you're asked to find the average rate of change, it's the same thing as the slope formula, right? So let's take a look. All right, this should be very much familiar to you in a review. So when we are looking at find the average rate of change between these 2 points, we're going to use the slope formula. So we're going to go negative 7 minus 6 and 2 minus negative 1. Keep in mind that I want my y's on the top, right? Change in y over the change in x. So now all I'm going to do, and again, if you have trouble with this, just use your calculator, right? Or you want to check your computation. We're going to get negative 13 over 3, right? Final answer. The average rate of change between these 2 points is negative 13 thirds. Okay, so now I want you to pause the video a moment and see if you can, right, do different representations. So one is a graph and one is on a table, but it doesn't matter, right? The average rate of change is still the change in the y's over the change in the x's. So pause the video and see if you can try these. Okay, so apparently there's a little typo on the graph. It says 1510. That's not a trick. It does say between 16 and 44. So that 15 was meant to be a 16 for this example. All right, so again, the whole goal here is to have 2 points, right, that I can take the change in y and the change in x. So instead of my just handing you the point, well, it's just on a graph, right? So our 2 points are 1610, right? And if you did it with 1510, that's fine. You'll be 1 off, and 4423. No big deal. The main focus is, do you know how to work the slope formula, right? So do you know how to do the change in y's over the change in x's? And you should have had a lot of practice with that last year. So negative 13, right, over negative 28. And again, a negative divided by a negative is going to be a positive. So you always want to have that in simplest form. There we go. Average rate of change, 13 over 28. Hopefully that's what you got. Okay, so hopefully you got to see that that was a graph, and it doesn't matter what data we're given, we're still doing the same thing. We're finding the average rate of change in y over change in x. So which has a greater rate of change over this interval, right? So those are your x's, right? So we're going to be looking at the same change in x for both f of x and g of x. Now, f of x, they've given us a table. Well, that's easy. We're just going to, again, where's x negative 2? Where is x 4? Right? So for the f of x, again, all we're going to do is the change in y over the change in x. And it doesn't really matter which way you subtract them. Ultimately, we're going to get the same answer. Right? So hopefully you got that decimal. And then if we take a look at g of x, well, now you have a couple of options. You could input, right, negative 2 and see what comes out, and then a 4, right? But you also happen to have a graphing calculator. So to be quite honest, I would probably just put this in my calculator and use the table. That way you don't have to deal with any computation, right? Just put that in your y equals, and then go to, all right, here's my table. If I put in negative 2, negative 49 comes out. And if I put in 4, 179 comes out. So you might as well use that fancy pants graphing calculator. So then when I go to do the rate of change for g of x, doing the change in y over the change in x, what do I get? Again, just use your calculator. Okay, so it's very clear, right, that 38 is greater than 13 and change there. So g of x has the greater rate of change. Okay, so hopefully that's coming back to you. All right, now let's talk about our 2 forms, right? Our point slope form and our y equals mx plus b form. So we're going to give you this problem and see how you can make sure you know how to use both linear equations, okay? So I'm going to have you pause the video again and practice. Just give it a try, and then we'll go over it. Okay, let's see how you did. Well, point slope form, which again, you had to memorize last year, really simple because they're giving you a slope and they're giving you a point, right? And the point is your x1, y1. So it's really just about substituting y minus the y value, put in your slope, and then x minus the x value. Now, of course, we're not going to leave that double sign. We all know that subtract a negative is add. That's it. All you had to do was use the point slope form and substitute numbers in. Now, if you look at part B, right, how do I go from point slope form to getting it in slope intercept form? Well, name of the course is Algebra 2, but it really is only Algebra 1, right? If you think about this, the only difference in these forms is that this one is solved for the y. So can I solve this for the y? I'm hoping yes would be my answer, right? So let's see. If I simply distribute and then add 1, right? Again, basic Algebra 1 takes me from point slope form to slope intercept form. That's all there is to it. You're basically just solving this equation for y. Okay, hope that went well and you're remembering that. All right, last page, we're just going to really look at a couple of word problem examples with slope and average rate of change. Okay, so let us take a look here. Suppose that the water level of a river is 34 feet and that it is receding. Now, receding is a very important word, and we've got a rate, right? So if I'm going to write an equation about the water level, where L represents the water level, well, what's happening? Well, I have 34 feet of water, and receding means it's going down, and the average rate by half a foot per day, and D represents days, right? So you should, again, be pretty familiar with writing this representation into a linear equation. Now, there's a part B. In how many days will the water level be 26 feet? Well, that's why I have an equation, because now I can just put the 26 feet in for the water level and then solve for my days, right? Which is, again, just easy peasy. Subtract 34 from both sides. I'll bring that over. -8 equals -0.5 days. Then we're going to divide by -0.5. Right? And so if you do that, we get 16 days. Right? And that makes sense if I'm receding half a foot per day. Think about it if you're starting at 34 feet. When will you get to 26 feet? Okay. Last but not least, for babysitting, Caleb charges a flat fee of $10 plus $15 per hour. Oh, do you recognize that rate? Right? What's his rate of pay? And then do you recognize that flat fee? Right? That's our constant. So write an equation where C is the cost and H is going to be the hours. Well, again, it's flat fee plus $15 per hour. All right? And then it just says, what do you think the slope and y-intercept represent? Well, again, the slope is going to represent the cost per hour. And then the y-intercept is that flat fee. That's just interpreting that. And then how much money will he make if he babysits for 5 hours? So just going to use the equation, right? The cost is $10 plus 15 times 5. That should give us $85. All right, I hope that was okay. Sorry, I'm not up to my best, but I thought a video might be better than not having one at all. All right, guys, I hope to get better and see you soon. And this is Action Jackson signing out.